So I'll bring this up again. We just collect email addresses. We do email blasts once in a while. I have a dual role. I'm going to talk about engineering with paper and all of that. I also run a program called Maker Ed with Make, and they run Maker Fairs and Make Magazine. So I do monthly workshops through that forum. And so getting your emails just gives me a way to tell you about all the workshops that we do through Maker Ed, plus show you whatever I'm doing on mine. So if you want to screenshot that or take a photo of that, and I will come back to that. Okay, let's get started. Oops. Okay. So I am based in New York City, and I run a hands-on program for kids. I have two physical spaces. One is a classroom space called Dazzling Discoveries, and the other one is called Skill Mill NYC. And that they're about one block apart in New York City. Skill Mill is a makerspace where we have all the equipment, laser cutter, 3D printing, etc. And then I've been working with kids for 25 years, working on hands-on. I was doing STEM before STEM was an acronym. And over that time, I've created some what we call products. One is a cardboard engineering kit that we sell. And I mentioned I'm not promoting anything about that today. And the other is a methodology called Engineering with Paper, which is how to make anything out of paper, tape, and scissors. And the idea is you can do hands-on learning anytime, anywhere, as long as you have those simple supplies. This is a quick overview of the kinds of projects that we talk about or that we have packets for. And I'm going to go through the logic behind this and then how this relates to CAD, because that's the theme of this presentation. I always put this up because during the pandemic, New York Times was running weekly articles about making things out of newspaper. And they published 4 of our projects over about a year and a half time period. And so we are official New York Times authors. We're on the website. You can search my name. I actually don't recommend making these projects out of paper. If you have the choice, copy paper or cover stock paper is better. But for the purposes of the New York Times, we did it. We were able to get the newspaper to work. Okay, so the idea is there are thousands of STEM and STEAM challenges. And what we've learned is that it's not the challenge that's the problem, it's how to use the materials and how to get started. That often trips up both teachers and students. And so some students will bring prior knowledge and some students won't. Where do kids get that prior knowledge? Some of them get it from their families, some get it from a prior class, but you don't have a consistent group. So we like to start with getting everybody on the same page. How do you prepare all the students to work on projects? So we call this core skills or leveling the playing field. And the idea is if you can teach all the kids some basic actions with materials, then everybody knows how to use the materials and then they can move forward on the challenges. And so we figured out a method for making what we call shapes out of simple materials. And I'm sure most of you are familiar with kindergarten blocks. They're standard shapes. There's the rectangular prism, there's the columns, there's the blocks, the square cube blocks, a few other triangle shapes. So that idea of having some standard shapes is what underlies the whole methodology of engineering with paper. We teach kids and teachers how to create some standard shapes, and they're different than the blocks might be, but it's the same idea. Several standard shapes can be combined in multiple ways to make really unlimited projects. So I'm going to show you some pictures of how that works, and then we'll connect that. So here's an overview of some of the projects, and these are all using simple shapes. So the track shape, which is a strip of paper with the sides folded up, is in Simple Machines. It's in the ramp. It's in the catapult. It's the bar for the balance beam. So sometimes the shapes get used in ways you wouldn't necessarily expect. The paper tray shape is in almost everything we do. It's the car, it's the Ferris wheel at the bottom. it's just in a lot of places. So there are 5 or 6 standard shapes, and they get used in multiple ways. And that way you're not dealing with too many concepts. The kids can just focus on knowing those shapes and then figuring out how to combine them. This is just an overview. You can use this methodology in any topic. It's not related to science or engineering specifically. I have a lot of people use it in history to create things that relate to periods of time. We have a mission to Mars idea that you can, because if you were going to go to the moon or to Mars and you just brought your supplies with you, you'd need to be able to construct projects. So you can see the link there. Lots of ideas. So here are some projects in action. And what I like to point out when I show these pictures is that these use just 2 shapes. So this is using the paper tray and what we call our paper tubes. And the tubes are just different widths, but they're just cylinders and paper trays. This is a roller coaster. Obviously, this is the paper track and rectangular prisms, 2 shapes. And you make the tracks in any way that you want. We have a packet that explains how to make corners. This one's just a drop corner, but there's also a 90-degree angle corner and a curved corner. So our packets explain a little more detail, but you can see what we suggest just from looking at these pictures. This is pretty simple. Just paper and making a parachute. This is one of our puppet characters. And this is actually the paper tray. It's basically the paper tray shape with a couple of extra cuts in it to make it fold in half. This is just strips of paper. This is a really good kindergarten beginner project. This is pretty straightforward. Puppets. I think you get the idea that it's simple but versatile. This is also just a strip of paper folded a few times to make it stiffer behind this puppet. It's actually 2 sticks. One is sliding in front of the other. This again is cylinders. It's a wider cylinder and a more narrow cylinder, and you can see the results. This is our paper car. This one I particularly recommend for older kids. It's a little more precise, but again, it's just the paper tray and cylinders, and then the circles that you cut for the wheels. This is our paper maze. And these projects work for almost, there's quite a wide age range. This is the balance beam. This is my favorite one, just because it's not what you would expect. You wouldn't imagine how you could make a balance beam with just paper, but it works so well. And it's a track shape for the top. It's paper folded into sticks for the support. And then it's strips of paper folded over and rolled to make the rings. But we've had kids make baskets, and you can make almost anything to hang off of the sides and to see. And it showcases the fact that you can't really see balance. You have to feel it. And you can see from this GIF that the hands are moving the bar a little bit left and right to get it to the right spot, because you have to feel where it is. You can't actually see it. But again, it's just paper, tape, and scissors. And then we have a whole series of things made with what we call paper straws or paper tubes. And then we have a little funny technique with a paper clip that you can open up into an L shape and keep the rounded edges, and they fit inside the tubes, and so you can build with them. We make all kinds of things with those 2 techniques. It's the only other material that we use besides tape. Okay, so my presentation today is how to combine some of this with CAD, and we do it in multiple ways. One is kids in our makerspace will make an animal, an object of some type, and then build the paper world around it. And this paper world is just 2 paper trays fit together. And actually, there's a little paper tray there for the bed, and then there's a smaller paper tray for the food. So you can see where the same shape, particularly when used in different sizes, can be many different things. And so when we're doing CAD work, we do two different things. Sometimes we have the kids draw the picture that they want to produce before they work with, and we work with Tinkercad. I'm assuming most of you know what that is. I'm not going to go into any Tinkercad instructions in this work presentation. But we will have kids draw things, and then you can see we have them think about what are the shapes that are in their drawing before they start using Tinkercad. And then they can go and find those shapes because they're all part of the Tinkercad vocabulary. And then this was just another example where somebody drew a picture and started to identify the shapes. And then you can see the model is made. And in this case, he used the scribble tool. So, and then again, building a world to go with the small 3D printed object. Because the 3D printing, in our experience, it doesn't take that long. And once they have that object, what do they do with it? So we like to combine that with the engineering concepts and adding to it and just making that 3D printed object a component. So I'll show you, we have a few examples of that. It's an airplane and an airport, heliport. These are projects kids came up with. We didn't tell them to do any of these. It's just whatever. We do teach them how to make these basic shapes. This is a little, I hope you can see the little animal in the front of this house. And here's just a few more projects where you can see the same ideas. But again, most of these projects are using our engineering with paper in basic shapes. So that's one way that we combine. And then, oh, sorry, just want to mention that what we do when we're coloring things, and you can see it in these, like in this flower and in this animal creature over here, we use permanent markers. They work great on the plastic, on the PLA, and it's easy, it's not messy. We don't paint anything, it's just not worth the effort. But we do find that permanent markers are really excellent for coloring. And we actually, at this point, we basically print everything in white so that kids can color it. We don't even bother with colored filament anymore. But that's our process. Okay, so the other way that we use engineering with paper is for the more complex projects. So if you're doing a roller coaster, we start by looking at pictures of roller coasters. And what we emphasize, particularly with roller coasters, is everybody thinks about the track. And that's what kids, if you just to say, go build a roller coaster, the first thing they'll do is build the track. But it's in a way the least important part. It's the supports that matter more than the actual track, because you have to be able to hold up the track. So we really emphasize the whole project as including the supports. We look at lots of pictures of roller coasters, videos of roller coasters, and then we build paper roller coasters. And we do that before we do any of the CAD work. And it could be this design, it could be cylinders. There's a lot of variations. The roller coasters don't have to look like this, but they start by building a paper project. And here's an example of a student making a double-decker roller coaster. And then once you have that, then you can go to Tinkercad and create the same shapes using either the existing shapes in Tinkercad, or you design your own shapes. And remember, they're very similar. The shapes that we are using match up very well with the shapes that are in Tinkercad. So it's a pretty easy transition for students to go from the paper model to the CAD model. And one of the things we find to be very helpful with students is because they have the three-dimensional model in front of them that they have already built, and they can rotate it so they can see it from different dimensions, and that helps enormously with the spatial reasoning of doing it in Tinkercad. And so I highly recommend doing whatever project it is to do it with paper first. It's the tangible. It also gives them a much more tactile sense of what they're trying to create. And then I assume most of you know what SimLab is. It's been out for a couple of years now. So I'm not going to run this little video, but it's an action process built into Tinkercad. So if you build something in Tinkercad and you design it in a particular way and you click run, it will turn it into a movable or a moving action. And so you can create a marble run and place a marble at the top and then have it actually run down. You can change the materials. So while our materials are paper in real life, on Tinkercad, you can make your tracks into metal or wood or ice, and you can make your ball into cement or rubber or anything you want. And it's really interesting to see the effects of the different materials. And sometimes the ball will bounce off of the track, and sometimes it will roll down. It goes faster and slower. It's really great. If you haven't used SimLab, I highly recommend looking into it. It's easy to find. It's part of Tinkercad. There's lots of videos on the site about it. So I'm going to go back to my engineering with paper because I think that's the part that is most interesting to you being part of this workshop. Before we do anything else, and I'm going to do a little modeling right now. I'm just checking the time. So we have about 25 more minutes. Great. Okay. We always rip the tape in advance. We have the kids do it or we do it, depending on how old they are. The youngest kids, we do it for them. But once you get to second grade, they can do it themselves. If you give them strips of tape, and we like to use scissors because you get a much straighter, cleaner edge, but it's hard. It's really hard to fight against that tendency for kids to rip tape. It doesn't really matter. It's just neater if it's cut. But it's really important to have tape pre-cut before you start, because in many of the parts, your both hands are used to hold the piece together, and you don't have an opportunity to then go get some tape. So we use masking tape. We don't generally use Scotch tape because it's harder to work with. It curls up. It's just harder to maneuver. But that blue painter's tape is fine. Washi tape's not so great because it's not very sticky. But in the end, it doesn't really matter what kind of tape you use. It does help to have it. We will often use the edge of a table. It doesn't have to be a cup or a bowl. We'll use the back of a plastic plate upside down and then put tape all around that. The tables are tricky because you never know what kind they are. And if they have paper on them or fabric on them, you can't put tape on them anyway. Sometimes we use the back of a chair, any plastic surface that you can remove tape from. Okay, so we're going to start by cutting some paper. We have a whole bunch of free downloads on our it's our dazzlingdiscoveries.com website. And then there's an engineering with paper link. And I believe there's also an engineeringwithpaper.com link to the same site. And there are many free downloads, one of which is what we call our folding and cutting guide, because part of this is not just the shapes being standard. We find it's very helpful to have the paper also standardized and have common shapes. In our space, we use a paper cutter and we pre-cut the paper. It's not worth the time to make the kids cut it, but that's up to you. We just like to we put the sizes in big Ziplocs. We keep big chunks of paper cut into these sizes and put them in Ziplocs and then have them available when we need them for the students. Okay, so I'm going to stop sharing this. I'll just give you this again quickly. Let's see, what else do I have? Oh, well, let me go through the rest of this and then we'll turn it off. You can follow us on Instagram. We have lots of projects on Instagram under Engineering with Paper. We have our Dazzling Discoveries, our Dazzling, so it's the cardboard kits that I make. And my email address is on there if you want to get in touch with me. We're going to do some hands-on. I'm just going to finish the slides. And then that's the QR code again, if anybody wants to join into the email list. Okay, let's stop sharing. All right, so I hope some of you were able to get some paper. If you joined in after I started, it's helpful if you can get some copy paper. It can be scrap paper. It can be any kind of paper. I don't know if we can spotlight me. What do you think? I don't see it in mine. I don't know. All right, well, either way, you'll get to see. So piece of some copy paper and a scissors and some kind of tape. And I'm going to show you what to do, and then you can decide what you want to do. If you can do it along with me or you just watch. So I drew, I'm going to hold this up. I drew the divisions on this. We don't usually do that. We usually just cut it, but it's much easier for you to see what we're going to do. So if you take a piece of copy paper, and we have some language that we use regularly, and I'm going to use that for this conversation. This is what I say when I do teacher workshops, and I do a lot of these workshops. And it's also what we do when we talk to students, because remember, this is all new. It's new to you, it's new to them. And so we like to have common language. One concept is what's an edge and what's a side. So in our materials, these are the edges. The outer lines on the paper are the edges. The sides are the flat planes. And we just make that distinction because you're referring regularly to the paper and how to fold it. And so when you're just creating the sizes, we take the full sheet of paper, and when you look at it, you can see that you have longer edges on the top and bottom and shorter edges on the sides. We don't use any of those food words like hamburgers and hot dogs that some people use, because we don't know where our students have been. We don't know what food they eat. We don't reference things that are not right in front of us. Everything we do focuses on what everyone in the room can see and do. So we talk about edges. And so the first thing is to take a full sheet of copy paper and fold it in half, short edge to short edge, lining up the corners. And so those are the words that we use. And then we try very hard to get everybody to learn how to crease or press that folded edge, because that is a common challenge for kids. As adults, we can understand the tactile of pinching and patching the edge, and kids don't. So I have a few techniques for that. When I try to have them do it on the table rather than I have to do it in the air to show you, but I have them do it on the table, and we always have markers or something. So we use a marker as a rolling pin over the edge. If you don't have that, and you could teach them to make a fist and use this part of their fist to rub that folded edge, just to emphasize that squeezing or creasing that edge that you've folded. It really helps with all of these projects. And in this case, we're just cutting, so it's not as critical. So if you have a scissor, or if you don't have a scissor, you can just fold back and forth and then rip it so that you will have two half sheets instead of one full sheet. So take your paper in half, and I just realized I will pull up. I have so many, you can see behind me, I have so much paper already cut. Keep my sizes here. I do this a lot. So then you have, then you take one of your half sheets and you fold that again. I just want to give you some different size paper to work with, because it's really fun to make the same shape in two different sizes and see the difference. If anybody teaches math, the shapes in multiple sizes is really great for ratios and proportion. But again, take your half sheet and fold it in half, short edge to short edge. And again, fold and crease that folded edge and cut that. So now you have what we call a quarter sheet. So you'll have one regular half sheet left, and now you've taken your other one and folded that off into a quarter sheet, right? So that's the basic idea. And let's start with that, because we don't have a huge amount of time. I want to show you how to make a couple of shapes out of these pieces. So the first and the most simple shape that we have is what we call our rectangular prism. And I always like to start with this because it really is so simple and weirdly inspiring. So you're going to take a full sheet. You're going to take one of the, well, we'll do two. Take one of the half sheets and take it and fold it in half, short edge to short edge, and press that folded edge. And then you open it up and you fold both the short edges to the middle. For kids, they really have to do this on a table. You're folding both into the middle. Sometimes I will come around and either have them do it or I will do it. I'll actually draw a pencil line. It's sometimes hard to see that folded middle. It just depends on the lights in your room. But once you fold this, we call this cabinet doors. And I generally can use that phrase because in my experience, at least the kids that I see, there's always cabinets in the classroom. And as I said, we only refer to things that everybody can see. So if you don't have cabinets, don't use that phrase. But for us, generally, I've never been in a classroom where there wasn't a cabinet. So, so now these cabinet doors, and you're going to take the tape and you're going to close the cabinet doors by putting the tape the tall way and closing those doors. So it's not origami. Origami has many folds. These are 2 or 3 folds at the most. And once you've put your tape on, you should be able to see. I see Marta's doing this with me. He's been to many of my workshops. So he even came and saved my laser cutter one day. So we're hoping you come back. So then you pop this open. And what do you have, right? A rectangular prism. So now what is this? Depending on where you live and what you do, it obviously could be a building. It can be an elevator. If you turn it sideways, it could be a tunnel. It can be a subway car. It could be a bench. So the idea is this simple shape can be many, many things. Depends on how you turn it. And then I'm going to show you how to turn it into a couch, which is for some reason one of the most popular things that we do. And we make some rooms out of paper also. We do a lot of structures. So I just realized that this isn't. So you're going to take your same, I mean, you can either make a second one or take the same one. But if you fold it, so my taped edge is here, flatten it back. And I'm going to draw the lines on it so that you can see what I've got. You're going, whoops. So then you can draw, you don't have to draw them, you can just cut. But you're going to cut not completely to this middle fold here. You're flattening it. My tape is over here. I have a folded edge here, and you're just going to cut 2/3 of the way in on this flattened rectangular prism. And then you pop that back open. And I have a smaller one here. So now I have that. And then you push that in. So after you've cut, you push it in. So then this becomes a couch if you hold it that way. I see somebody smiling. That's what I get all the time. I love it. It's great. It's so much fun. If you turn it this way, it can be a window. It can be a ticket booth. I had somebody turn it into a fireplace. So remember, the point of all this is not that we make exact things. It's that we're using these shapes and these actions as part of something bigger. And these are just the techniques so that you can then be inspired to make many things from this. So that's our rectangular prism. I'll show you, you don't have to do this, but I will show you a couple of other things you can do with it. So this is another one, a bigger one that I have. So one of the things to make it accessible and to attach it, there are two things you can do with this next feature. We cut slits. You're welcome to try that if you want. It could be 1 inch or 2 inches, depends on the size of the piece you're using, so that you create these flaps. And you cut them down on the folded edges, and then you can fold these out. And the advantage of this, Same rectangular prism, just a couple more cuts. Again, remember, we're staying in this theme of using the supplies, using the shapes, learning that these shapes can be adjusted in small ways. But for the kids, it's fabulous because they make that link. They remember the shapes. They can learn these little steps very easily. So now that you have this, it makes it much simpler to attach the this building or structure. We also use this for our roller coaster. It makes it much easier to then just tape it because now you're on the same literal plane when you're taping instead of that thing that kids will do with making the tape curve and trying to get things to stick. This is a much more effective way to attach perpendicular pieces that are going different directions. So these are called flaps. I had somebody tell me it was one of the best things she ever taught her students how to do because for that they use less tape, their projects are sturdier. The other way you can use these flaps is the reverse. Turn them in if you want to close off the top or bottom of your project. So if you take those same flaps and you fold them in, and this one, you have to measure it a little bit. It depends if you want it to close up the hole or not. So that you would just measure in advance how far those should be, but you see the concept there. So now you have a closed box. And if you wanted to, you can do the same thing on the other side and close it up. And if you're teaching math, you can take this rectangular prism, do the measurements so that when they fold the sides in, they have a cube. And so that's one of the many math extensions on this particular shape. Any questions about this? Does that all make sense? I will say that for most of our projects, cover stock, I'm actually using cover stock paper here. Cover stock is a little bit better than copy paper, but we designed everything to work with copy paper. We want this to be as usable as possible. We want everyone to be able to do it wherever they are, whatever they have. And people don't always have cover stock. When we're rolling the paper into cylinders and definitely straws, you must use copy paper. It has to be the softer paper, rolls more easily. Cover stock does not roll well. But in terms of structural shapes, the copy paper is a little bit, can be a little bit flimsy. Sometimes we fold it over and double it. That helps a little bit, but everything will work with copy paper. Okay, what are we up to here? So I want to show you two other shapes, just so you have that. The really simple one is if you take, let's see, what should we use? We used up the half sheet, right, on this. So you should have a quarter sheet, and we can we're going to take that quarter sheet. And so we have two different directions that we cut in. One is what we call chunks, which is when you've got sort of that almost square, but not quite, little, kind of rectangular. And then we have another direction that we call strips. So you're going to take, you should still have a quarter sheet. So you're going to take the quarter sheet and you're going to fold it long edge to long edge, fold it in half. And if you're using copy paper, I would just leave it like this, and I'll show you the next part. If you're using cover stock, you could cut this into two pieces, but you want it to be a little bit stiffer. So generally, when you're dealing with paper, it's very, it's a little better when it's this big piece. So paper's generally floppy. And sometimes you need it to be stiffer. So one way to make it stiff is to fold it in half and thicken the paper, but it's still flimsy. And so the way that you can stiffen the paper and make a paper track is you fold the edges, and it depends on what you're making, how high the walls are. So here's one that I made. It makes a kind of and you can see it just makes a really simple track. There's no tricks to anything I'm doing. It's all very, very simple and straightforward. So you fold up the sides. Sometimes you can fold them to the middle if you're looking for a way to have kids do it symmetrically and do it all the same. but it doesn't really matter. It matters what you're making. And so this basic track shape is great to have. And this is what we use for our balance beam. You probably can take the piece you have and try to find the balance point on it. We use that piece for the roller coaster. If you're making a roller coaster, what we do is we take, and you can cut these down. They're in different lengths. As we said, they're different sizes. But usually we take this edge and tape it. So where my fingers are, that you'd put a piece of tape there, and then you have the beginnings of a roller coaster, right? And as I said, in our packet, we have ways of turning the corner. You can make 2 columns, as I think I had in the video. So that's the track shape. And the third shape that I want to show you is the paper tray shape. So we can take whatever pieces you have left. Yes. Okay. So you can take any size, it doesn't matter. And the idea of the tray is, so we just did with the track, we folded up 2 sides. What you do for the tray shape is you fold up 4 sides. And so you're folding and unfolding. And again, this is where that getting them to really press that folded edge, make that crease sharp, make it tight, it really helps. So you fold and unfold all 4 sides, and then unfold them. And again, these are all line art, very simple instructions in our packets. They're downloadable instructions. You can either look at them on a screen or print them out. Often we'll put them up on a big whiteboard screen in the classroom, and we don't even print them. Sometimes we print them and put them in sheet protectors, put them on the tables, but it's all in our materials step by step. Every single step is in there in black and white line art. So it's easy to print the papers if you want them. So then you have 4 folded edges, and then you probably, so you can see that it makes a kind of a square, and then we just mark the parallel spots. Can you see that? I know I could do this on a slideshow, but 1, 2, 3, 4, and you just snip those 4 spots. And once you've done that, I'm just using ones that have already been folded, you get a corner. And so if you tape up all 4 corners, you have a paper tray. And that tray can be as big or as small as you want it to be. It could be the base. This is a full sheet. This is a half sheet. You saw in the pictures, the kids are making really small ones we actually go down to 1/8 of a sheet of paper. They use them for beds. And if you put 2 of these together, you make a bunk bed. If you put a top and a bottom and some walls, you have a house. It's just, there's no limit to what you can do with the paper tray. I actually use them sometimes when I go to schools. We'll make paper trays when we get there to put the markers in them so they don't roll off the table. You can have them, you can stand them up, and they could be a bookcase. They could be whatever anyone thinks they are. They're, again, the idea is there's no rules to this. There's no right or wrong. It's just using these basic materials. And then, so those are really our most common shapes. And if you already have them and you want to cut some more paper and make a few different sizes of the trays and the rectangular prisms and the track, you will automatically start playing with them. I do this workshop in person a lot. And as soon as we have a collection of these samples, people start playing with them, stacking them, putting them inside each other. And that's what kids do too. That's what you want. It starts to inspire their thinking, and then they're building from there. I'm just trying to think if I have Okay, let me show you one more. This is just a really quick, so all of these shapes relate back to Tinkercad. You use them all in Tinkercad. They relate very well to whatever you're using in Tinkercad. But as an aside, not necessarily a Tinkercad thing, we do a really quick thing we call a paper corner, which is a full sheet of paper. We fold it in half, short edge to short edge, and then rub that crease, and then open it, and then fold it long edge to long edge. So basically what you're getting is a cross in the middle of your paper. And then on the longer edge, we cut a split to the middle. This is pretty simple. And then you overlap it and you get a corner. And I cannot describe, I mean, I didn't put the pictures in my slide presentation because I wasn't going to go into this because I do a whole workshop just on this. It is one of the most inspiring things we do. As soon as the kids see this, they see possibilities. They see a room, they see a park, they see, I don't know, what else, schoolyard, they see anything. And when we have them, we don't have them tape it yet. We have them draw on it. So they're drawing the background on this part and then the floor here. And then they take the shapes that they've built. And what did I do with my little couch? But if you take your couch and you put it in here, you put your couch in the room, and suddenly you start to have, you see, I think you understand what I mean. You will have your, there you go. And then it goes on from there. Let's see, we've got like 5 more minutes or 4 more minutes. I'm going to show you one other thing. This is our paper catapult. This is the most popular thing that we have on our site. It is definitely a free download. It is how to make a catapult out of a single sheet of paper. So I highly recommend going to my website and downloading this. There's also a small roller coaster that's free. The cutting guide is there. The paper corner is there. There's a whole bunch of free. And then we charge for some of the packets because when you see them, they're very detailed and it takes us months to create them. And I pay somebody to do that. And so it just recoups a little bit of what I've spent to create them. They're not expensive there. And you use them as much as you want, use them for as many kids as you want. We don't track anybody, but it just helps us recover the costs of making it. So this is a catapult made out of a single sheet of paper. It's basically a piece of paper cut in half, and one half is used to make the arm, which is a track. The other half is used to roll up the fulcrum. It gets taped together. And then we cut a little bit off of the end of the track and roll it up into a cup, which is another cylinder. So remember, 2 shapes, going back to my original point. Everything is made with simple shapes used in many different ways. Okay, we're going to be out in 1 second. So go to my website, dazzlingdiscoveries.com, and download the free projects. And thank you so much for participating.